Experiments on the evaporation rate of water. This video presents quantitative experiments measuring the evaporation rate of water. 1 milliliter of water was placed in an isolated tiny basin formed by a magnetic ring, with a base cast from a homemade mixture of black carbon powder and white cement in a 1:1 ratio by weight. The first clip demonstrates the full procedure. Please watch carefully. Step 1. Form the tiny basin. A magnetic ring, inner diameter 25 m, outer diameter 43, height 10 m is placed on a stainless steel knife blade. A drop of vegetable oil is applied to the inner wall of the ring to act as a release agent. Step 2. Prepare the casting slurry. Blend black carbon powder and white cement in a 1:1 ratio by weight, then add water at a water-to-powder weight ratio of 1:1 and mix until a uniform slurry forms. The consistency should resemble yogurt. Step 3. Cast the tiny basin. Slowly pour the slurry into the mold. Transfer the mold and knife blade to a cool, shaded area to cure. Once set, carefully detach the assembly from the knife blade, then demold the disc from the magnetic ring. The material is quite brittle and prone to cracking, so handle with extreme caution during demolding. Due to the coarse particle size of the raw materials, the disc surface will be rough and uneven. This is expected and does not affect performance. In fact, a rough, pitted surface enhances light absorption and photothermal conversion efficiency. Note, white cement is not essential. As discussed in previous videos, white surfaces reflect sunlight and reduce photothermal conversion efficiency. Cement serves purely as a binder. Any dark-colored hydraulic binder is suitable. The finished products, disc and tiny basin. The disc is cast from the homemade slurry and carefully demolded from the magnetic ring as described above. The tiny basin, consisting of the magnetic ring and the disc, serves as the experimental vessel. Each basin was tested for leakage prior to use in quantitative measurements. Evaporation rate measurement. 1 ml of water was placed in the tiny basin. The entire assembly was set inside a larger vessel filled with water, with the outer water level flush with the top surface of the magnetic ring. The water level inside the basin sat slightly below the surrounding water level. Sunlight was concentrated onto the base of the basin using a Fresnel lens. Some light inevitably struck the inner walls and upper rim of the ring, resulting in minor energy loss. Under these conditions, 1 ml of water evaporated completely in approximately 1 minute 41 seconds. 3 parallel trials recorded durations of 1:41, 1:41, and 1:43, demonstrating excellent reproducibility. Experimental conditions. Ambient temperature, 23 C. Fresnel lens aperture area, 0.0706 m2. Estimated evaporation yield, tons per square kilometers per day, based on 10 hours of daily sunlight. The evaporation efficiency of this homemade solar concentrator is modest, but the results are practically meaningful. Exciting carbon suspension test. In a separate experiment not shown in this video, water was replaced with a 15 Wt% black carbon powder suspension. The evaporation time dropped to approximately 40-45 seconds per milliliter, roughly half that of pure water. The projected evaporation yield rises to approximately 11,000 tons per square kilometers per day. This series of experiments aims to identify materials with high photothermal conversion efficiency and broadband absorption of solar radiation across different wavelengths. Next video. It is reasonable to predict that the evaporation rate will approximately double when only 0.5 ml of water is used in the same tiny basin due to the higher surface area to volume ratio. The next video will test this hypothesis directly. The carbon suspension results suggest a promising direction. A cost-effective material capable of doubling the evaporation rate warrants further investigation.